Welcome back to the workshop. We want to continue taking a look at section 2.6 on applications. And the last thing that we talked about were combinations or N choose R, that sort of thing. So let's take a look at some examples where we're just trying to compute some numbers. So let's compute the combinations of 16 choose 5, right? So we have 16 objects. We have a set with 16 objects. We're looking at the number of ways that we can choose 5 of them. So the number of combinations of 16 elements, choosing 5 of them, is 16 factorial divided by 16 minus 5 factorial times 5 factorial. And this would be, of course, 16 factorial still times, or over 11 factorial times 5 factorial. Now, there's a bunch of simplifications that can happen here. So I'm going to go ahead and do it in 2 steps, at least this first time. 16 factorial is 16 times 15 times 14 times 13 times 12 times 11 factorial. Divide this by the 11 factorial times 5 factorial. And actually, the 5 factorial I'm going to write out as 5 times 4 times 3 times 2 times 1. So now I can recognize that 11 factorial and 11 factorial will cancel. Let's see here, 5 times 3 is 15, and 4 times 2 is 8. 16 divided by 8 is 2. So this gives me 2 times 14 times 13 times 12. For a grand total of 4,368. So there are 4,368 subsets containing exactly 5 elements for a set that originally contained 16 elements. Or you can think of it as, right, it's the same thing here, or it's the way to choose 5 things from 16. All right, so what about number of combinations of 5 choose 2, right? So 5 choosing 2 elements would be 5 factorial divided by 5 minus 2 factorial times 2 factorial, which is 5 factorial divided by 3 factorial times 2 factorial. Again, this will simplify a little bit. So this is 5 times 4 divided by 2 factorial because the 3 factorials cancel out. But 2 factorial is just 2 times 1. 4 divided by 2 is 2. 5 times 2 is 10. Now, this should look somewhat familiar to us. We saw this thing right here, 5 factorial divided by 3 factorial times 2 factorial. Let's see here. We saw that right here, right? 5 minus 3 factorial is 2 factorial. So it can actually be shown, right here I chose 3 from the 5. Here I'm choosing 2 from the 5. It can actually be shown that, so it can be shown that when we take the number of combinations of R elements from N, this is equivalent to choosing N minus R elements. So when I have 5 elements, I can choose 2 of them. If I choose 2 of them, then what have I effectively done? I've chosen 3 not to include. So if I include 2 things, then I'm not including 3 things. So choosing 2 is the same thing as choosing 3 in terms of counting. Okay. If I have 10 things and I choose 4 of them, that's the same thing as choosing 6 of them, okay, in terms of counting, 4 and 6. Right. So what about this last example here? Let's see. We have combinations of 4, have 4 elements, choosing 2 of them. That would be 4 factorial divided by 2 factorial times 2 factorial, plus 4 elements choose 3, so 4 factorial divided by 3 factorial times 1 factorial. 2 factorial is just 2. Well, and there's a little bit of reducing here. So 4 times 3 cancels out because we cancel out with a 2 factorial, and we're just left with 2 times 1, the other 2 factorial, plus 4 factorial and 3 factorial reduce. So we've just got the 1 factorial left in the denominator, which is just 1. So 4 times 3 is 12. 12 divided by 2 is 6, plus 4, which is 10. Hey, doesn't that look really familiar again? That's what we found up here and what we found up in the last problem. Well, yes, it is, because another interesting thing, it can be shown that the number of combinations of n minus 1 choose r minus 1 plus the number of combinations of n minus 1 choose r of them is actually equal to the number of combinations of n choose r. So our n in this case would be 5, and the r in this case would be 3. 5 choose 3. That's exactly what we had up here, which we already said is the same thing as this. So cool. Anyway, these additional comments in black aren't actually necessary for our understanding of the material. All that we're interested in this case is simply, can we evaluate this thing? Well, write it in terms of factorials, simplify it, and we get an answer. That's all that we really needed to take away from these examples. So hopefully you're able to do that. All right, that's all that I wanted to share for this video. We do have one more video on counting that will also be relatively short. So I'll see you guys again soon here in the workshop.